Okay, the lab for tomorrow is aldaric acid, and we are going to begin with galactose, which has an OH, H, and OH, H, so each intersection is a carbon atom, H, OH, OH, H, and a CH2OH. And we are going to convert it into, oxidize it into aldaric acid. So the aldehyde is going to get converted to the carboxylic acid. The rest of it remains the same. Primary alcohol also gets converted to the carboxylic acid, and this is achieved using HNO3. So first things first, what do we know about galactose, the starting material? Galactose is a sugar. It's a reducing sugar. It's a diastereomer of glucose. So when you look at this molecule, something should click. One of those things is the presence of 4 chiral centers, and that means that 2 raised to the power of n, where n is the number of chiral centers, you have 16 diastereomers possible, one of which is glucose as well. Now, if you take galactose, and so this is galactose. If you take galactose and you take an optical rotation of that, you will get a finite value. Your product, which is aldaric acid, also contains these chiral centers. But notice, in addition to that, it also contains a plane that goes through the molecule and divides the molecule into 2 equal halves. What does that mean? There's one word which will describe it all. You got it. It's a meso compound. So what should you get in the optical rotation? A value of 0. So one way, and we are not going to follow that way, but one way that you could determine whether or not your reaction has gone through is you could use a polarimeter. You could get the optical rotation of the starting material, you could get the optical rotation of the product, and compare the two things. Now let's talk about why nitric acid. In class I gave you a boatload of other oxidizing agents like KMNO4. You could use periodic acid, you could use dichromate. So what's going on? Turns out each of these has a problem of its own. Things like KMNO4, for instance, would themselves get reduced to MnO2, which is a brown solid. So it's going to stick to your precipitate, stick to your product, and it'll be very difficult to completely get rid of that MnO2. Periodic acid, it's in the nature of periodic acid. Recall from organic 1 that if you have a diol, it's actually going to cleave right here in the middle, so it's going to actually rip the molecule apart. Dichromate, that's a toxic compound and also gives you low yields of the final product. I call dichromate a toxic compound just because, not by itself, but the chromium that you have is in the +6 oxidation state, and +6 oxidation state should not get into your system, essentially. So what happens in this case? What happens to HNO3 when the oxidation takes place? You reduce that to 2NO and 2H2O. Now you might wonder, well, NO is a colorless gas, but as you will read through the procedure, you will see that brown fumes appear. So what are the brown fumes due to? Let's take a look at the procedure and discuss that as well. The way you would run the experiment is you will start with a beaker. You're going to add 6 milliliters of water. To that, you're going to add 6 milliliters of nitric acid. The nitric acid you will use is the one in the hood, so it's a concentrated nitric acid, and we are basically diluting it a little bit. Nitric acid is corrosive, so it's a good idea to avoid contact with skin and clothing. That basically means that you would be wearing gloves at all times. You must obviously wear the safety goggles and your lab apron. This is the dilution of an acid. That means hydronium ion is going to get generated in the system, and the bond making is an exothermic process, so you will feel that the beaker is going to get hot a little bit. You're going to add 3 grams of galactose into the system, and you would see most of it should dissolve. You may use a stir bar to stir it in the beginning, but you will have to set up a steam bath, and so it's a good idea to just swirl it occasionally, rather than have a stir bar in there at all times. Now, once everything is mixed and you have stirred the mixture pretty well, you will set it up on a steam bath. That means you're going to use that metal container. So if I were you, what I would do is, one of you, as you get into the lab, get the steam bath started, because the water does take time to get converted into steam and to get heated up. You have to give it a gentle heat, and the sugar, of course, is going to get into the solution. So your solution will start looking, it'll go from colorless to kind of like a faint yellow to the color of sugarcane juice, and it will intensify. If your color starts to look very, very, very brown, not a good sign. So then you'll have to start over. But usually a goldenish sugarcane type of a color is pretty normal. And when that happens, an exothermic reaction will take place. So you will see brown fumes come out of the reaction mixture, and it's pretty dramatic, it's pretty intense, that you're going to see that. So what would you do at that point of time? And first of all, what are these brown fumes? Recall I said that nitric acid is going to get converted to 2NO, and NO is colorless. So what's going on? Well, the NO comes in contact with molecular oxygen in the atmosphere and instantaneously gets converted to NO2, which is your red brown fumes. Now, the NO2 can react with water, and it can give you HNO3, which is why we are running the entire reaction in the hood, because we don't want to inhale, we don't want to get a whiff of the NO2. And if you do end up getting a whiff of that, you will feel like a burning sensation in your trachea and your esophagus, your food pipe and windpipe. And so if you feel a little giddy, not up to the mark, please let us know. You will continue to keep warming the mixture as that exothermic reaction, that red-brown evolution of fumes, keeps on going until no more fumes are being formed. And at this point of time, your slurry that you have, that's going to start generating like a white solid along the sides. And for some people, it's again so dramatic that all of a sudden, like, they have nothing, and then the next moment the product just crashes out. For some people, it's a little bit slower, and they would see solid appear on the sides. But all in all, the solid is going to take over the beaker, and it's a pretty dense white precipitate. It's kind of difficult to miss it. At that point of time, you should remove the flask from the bath and add crushed ice to quench this mixture, and basically get the volume up to about 25-ish to 30 milliliter. You don't want to put too much ice, because if you do that, then at the end of the day you would be kind of picking off pieces of crushed ice from the filter paper. Just give it some time, stir, swirl, have it cold. So if I were to add the ice, I would do it in lots, and as you do it, beat it a little bit, so that quenching and that release from the acid bath essentially occurs in a very nice and efficient manner. At that point of time, you would then set up your filtration flask. So that's your filtration. The Buckner funnel is what you're going to use, and you're going to pour down through the filter paper. And you will get rid of the white solid that has precipitated. Wash it with 3 10 milliliter portions of ice water and allow the product to air dry. And as you filter through and you air dry your product, we are actually going to also start the oven. So if need be, you can also dry this in the oven. The melting point is so high that we'll be okay at 100 degrees. And then you're going to essentially weigh the sample. You're going to calculate the yield, determine the melting point, get an IR, and do a chemical test. Let's quickly go over that. So you'll weigh the sample. So we'll be doing a percent yield. We are doing a IR. We are doing a chemical test, and we are going to do a melting point. And it's a comparison of the melting point of the starting material and the product, which is going to give us, the difference. First thing about the melting point, if you think that as you're heating, irrespective of the temperature, if you think that the color is changing, that will basically mean that it's going to go through a decomposition process, and sugars in general do so. So record that. Record what you see. If you see a change in color, record that. We will provide you the IR of the starting material. You will be taking the IR of the product. The chemical test is obviously something that you do at the end of the day, and you can, if you want to, you can run both of those parallel. What you're going to do is you'll begin with galactose and put it in water, and here you'll have galactaric acid or aldaric acid, let's just call it aldaric acid, plus water. So just a pinch of that and 1 milliliter water. And to that you're going to add 5% sodium bicarbonate to both of these. It's in the nature of aldaric acid because it's like vinegar. It's going to give you protons, and those protons are going to simply react with the bicarbonate, convert it into H2CO3, which is going to decompose to water and CO2. What does that mean? That means that you're going to see fizz, bubbling, in case of aldaric acid. Galactose is just sugar. Nothing is going to happen there. There's no protons coming in, and so you're not going to see any fizz in that situation. You're going to record that exactly as I have told you in the past. So it will be a 3-column little table where you have the experiment. You're going to write down your observation. Some of you just say pink. Pink what? Pink color. So in this case, it's formation of bubbles observed. So write down like a sentence, not, pink. What's pink? And then inference. And of course the melting point of the starting material, and the melting point of the product. If I were you, I would manage my time, since the heating process does take time and you don't have to do anything once you have set it up. If I were you, I would go get the melting point of the starting material ahead of time, so that, and you do 2 of each. ahead of time because you want to make sure that you have enough time to get both of the starting material and the product done in a timely manner. So chemical test, of course, that's a 2-minute reaction. A percent yield, that's just something that you will do in your own time after you have taken the mass measurement. But again, I provided you guys like a little table, observation table, as to how to go about it. Give me the mass of the filter paper, give me the mass of filter paper or watch glass plus the product, and hence the mass of the product, and then the moles. Show me some calculation. Some of you do a great job doing that. Some of you not quite so much. Don't show me anything. Again, each of this is worth points, and the lesser data that you show, the worse it becomes for you. So please make sure that you take the time to complete your data table. The sample of that is available under Blackboard, so please take the time to go over that. And I'll see you in class.